Okay, hi guys. So in this lecture, we'll be seeing outer electronic configurations. Okay, so electronic configurations of elements. So let's say element is a S block element, then the outer electronic configuration would be NS1 or 2, and if the element is a P block element, then the outer electronic configuration would be NS2, NP1 to 6. If it's a D block element, then it would be N-1, D1 to 10, and NS1 or 2. If it's a F block element, it would be n-2 f1 to 14. It can be a number from 1 to 14, n-1d 0 or 1, or and ns2. Okay, so next we'll be seeing an important example wherein you have to write the electronic configuration of Z with atomic number 74. So for writing it, so first let's say I was xenon 54, means after the configuration of xenon only, we'll be writing just the configuration for the later part after this inert gas. Okay, so xenon has the atomic number of 54, and after 54 how many electrons are remaining? 20 electrons. So after xenon, let us fill them. So we'll be starting off with 6s2, then 5d1, 4f14, and 5d3. Why 5d1 is filled ahead of 4f? Because of the exception in electronic configuration in F block elements, wherein D, the first electron would be entering D, then the electron would be entering for 4f subshell. So this completes 3 electrons. Now we have been left with 17 electrons. 14 are filled in F block, or rather F subshell, not F block, and then the remaining 3 would be filled in 5d. And similarly for atomic number 111, let's say we have element Y, so we are filling it or having the configuration of it with first filling with radon 86 this is the inert gas. So number of electrons remaining after 86 electrons are filled with radon in the configuration, 25 more electrons are remaining, so just fill that with 7s2 6d1. Again 6d1 would be getting filled ahead of 5f14, but just for 1 electron here. So we'll be having 7s2 6d1 5f14 and 6d8. You can calculate total number of electrons as 25 here. 3 plus 8 11, 11 plus 14 25. Okay, so now what is the thing that we are missing here? In case of 7 rather than Z74, we can actually have so 5d is having 4 electrons and 4f is having 14 electrons, but if you look closely at it, 5d is just 1 electron missing from half filled configuration. So what will happen is it will take one of the electrons from higher energy level, in this case 6s. So by taking that, 6s2 would be converting it to 6s1 and 5d4 would be converting it to 5d5. Okay, so this would be the configuration of Z74. Now let's talk about the configuration of Y111. For the configuration of Y111, again we have, this is radon. So again we have radon here 86, and here we have 5f14. I'm just writing here. We have 7s2, which would be given to one of the electrons for 6d9. 61 plus 6d8 would be 69, or 6d9. I'm just writing here. Okay, so 6d9 lacks one of the electron to get completely filled orbital. So one of the electrons will be getting transferred from 7s2 to 6d9. So hence 7s1 would be remaining and 6d10 would be there. So this is completely filled d orbital. Okay, so this would be the final configuration of Y111. Okay, so let's see another example wherein we have to write the electronic configuration of X with atomic number 70. So first write Xe54. Number of electrons left now would be nothing but 16. So you can just put in 6s2, then 5d1. First electron would be entering D subshell and then F subshell. So 5d1 and 4f13. Again, the as F subshell is only lacking 1 electron for the complete filling of this subshell, hence it will take the electron from the higher energy level orbit or rather orbital, which is 5d1. So it will be converting into 4f14 and 6d 6s2. Similarly, if you see another atomic another element with atomic number 103, so what will happen in that case is, oops, I think something wrong happened here. Yeah, so what will happen in case of Y103? That would be, again, you can have radon 86, then remaining electrons you can fill with first 7s2 first, then fill the first electron in 6d and remaining electron in 5f. So we will have 7s2, and again shifting of one electron from 6d orbital to 5f orbital will take place. Why? Because 5f orbital is just lacking one electron in getting a complete filled f subshell. Hence it will take the electron from the next higher energy level, which is 6d, to get something of this configuration. Okay, next question is, you have to find all possible values of n and l, where n plus l is equals to 4. So let's say first we are taking value of n is 3, so l would be 1, so this will form our 3p orbital, which is possible. Next, if we take n as 4 and l as 0, so we'll have 4s orbital, which is also possible. But if we take n as 2 and l as 2, or we go beyond taking n as 1, so this won't be possible, as 2d orbital does not exist. So now in the next question you have to find all possible quantum numbers for the last electrons for sodium metal. Okay, so sodium has an atomic number of 11. You can just fill it, rather fill in all the configuration with 1s2, 2s2, 2p6 and 3s1. Total number of electrons 11. 2 plus 2 plus 6 is 10. 10 plus 1 is 11. So for the last electron, which is entering the s orbital, n is 3, l is 0, m is 0, s can be either plus half or minus half. These are all the possible quantum numbers for the last electron of sodium metal. Now let's actually see another important formula, which is magnetic moment. Okay, so magnetic moment, or mu, is nothing but root of n multiplied with n plus 2 Bohr magneton. Okay, the value is Bohr magneton. Okay, so where n is the number of unpaired electrons. Okay, so if you look at the electronic configuration of Zn plus 2, you have to determine which of the following two has zero magnetic moment. So if you write the electronic configuration here, first let's write the electronic configuration of zinc. So it would be, zinc has 30 as the atomic number. Okay, so 1s2, 2s2, 2p6, 10 electrons filled. 3s2, 3p6, 18 electrons filled. Then 4s2, 20 electrons filled. Then 3d10, 2 electrons remaining are also filled. Now plus 2 state, the outermost shell is 4s, or subshell is 4s, so the 2 electrons will be leaving from here. So apart from this, after the leaving of these 2 electrons, all the electrons in the subshells are paired, hence number of unpaired electrons are 0, hence magnetic moment will be 0. Next, let us see the magnetic moment in case of Cl-, where we have 17 electrons. Total electrons in Cl- would be 18. 17 were originally there in Cl atom, and 1 is acquired from outside to convert the chlorine atom into Cl- ion. So total number of electrons here would be nothing but, here total number of electrons were 28, and here total number of electrons would be nothing but 18. So just writing the electronic configuration based on 18 number of electrons. Okay, so it would be 1s2, 2s2, 2p6, 3s2 and 3p6. Total number of electrons here are 10 here and 8 here. Total is again 18. So total number of unpaired electrons here would be nothing but 0, hence magnetic moment would be 0, because magnetic moment is under root of n multiplied with n plus 2. If n is 0, whole magnetic moment would be 0. And if you look at the electronic configuration of Cl2, chlorine, not Cl2, chlorine would be 3s2 and 3p5. The last electron would be entering the p subshell, hence it would be converting itself into 3p6. Okay, hence with this we come to the end of this lecture. In the next lecture we'll be seeing some more examples, and then we'll be starting off with Schrodinger wave equation. So till then, good luck and goodbye.